Okay, for question 9, we're going to get a much clearer idea if we go in with an idea of what it looks like. So if we sketch it. So I'm going to sketch this one, and we don't actually know how to sketch it yet. So let's do a quick table of values. X, Y. Let's do -5, -4, -3, -2. That was a bit idiotic of me, because I know that if I do like, let's do -3, -2, -1, 0, 1, 2, 3. So Y, we're going to have -3 squared is 9. 4 take 9, can't do. -2 squared is 4. 4 take 4, 0. -0, 0. -1 squared, 1. 4 take 1. So we've got -√3, -√3. And it's going to be -2. So this is going to look like so we've got zeros at 2 and -2. What is this going to look like? Now I'm really confused. So it's going to go through here, here, here. So it's literally going to look like that, and then it's going to stop. So in order to have an inverse that's also a function, we need to be able to pass the horizontal line test. But here you can see it clearly fails, but if we restrict the domain to just either the positive half or the negative half, yeah? So x bigger than or equal to 0. Well, technically we want x to be between 0 and 2, because there's no point chucking anything more than 2 in. If we now draw the inverse, I'm not going to bother like finding the equation of the inverse. I'm just going to do it. It's going to go up to 2. 1 -√3, so -√3, 1. So it's going to look like that. Let me double check that. It doesn't look quite right, does it? Oh, I just can't draw, that's the problem. So technically, this is actually, because I'm not doing it to scale. Okay, let's do it to scale. Let's do a good job. Fine. No, that's not a rubber. Okay. Okay. So we've got zeros at -2. +2 went down to here, and it was literally a semicircle. And we're just going to restrict our domain to this bit, which means our new one is going to look like that bit. So that's the inverse. Because this would have been the horizontal line test. Okay, 9b. we've got 1 on x squared. Now this is a good one to have up your sleeve. So being able to sketch this one quickly, we haven't learnt it, but it's just, you know how a normal hyperbola is like that? Well, this time, this one is up here. So you can see really clearly how we failed the horizontal line test, which means we just need to restrict our domain here. I mean, we could do it here, same diff. So if we restrict the domain to just positive x's, then we're passing the horizontal line test because we no longer have the other bit. Which means if we're now reflecting that on that, if I've got y equals 1 on x squared, x equals 1 on y squared equals 1 on x, so we've got y equals the square root of 1 on x. That's going to look like that. Mostly because I was like, I can't figure this out, so I'm just going to reflect it along here. Yeah? Okay. Question C, x cubed take x. Which is the same as x outside of x squared take 1. Okay, we don't quite know how to draw this yet. I haven't taught you guys how to draw it. So let's just do x, y, minus 2, minus 1, 0, 1, 2. Minus 2 out of minus 2, negative 6. 0, 0. Hang on, what's going on? I'm going to chuck some values in between because obviously I'm not getting what I want there. So if I do a half, then I've got a half outside of quarter take 1. Oh, that should have been negative half. Okay. So it's going to look like, you're not going to get one like this in the exam, by the way. Hang on. It's been a while since I've sketched cubics, okay? So when we sketch this one, and you don't really learn how to sketch them properly until you've done differentiation, so please don't freak out that you can't do this. It's got intercepts at 0, negative 1, and positive 1, yeah? And it's going to look like this. So if we restrict our domain to down here and to up here, then we're fine. Because if we restricted it to down here as well, we would have failed the horizontal line test. But I can't have them both equal it because then it's going to fail the horizontal line test along there. So why don't I have one of them? Why don't I have this one not include that point? So I'll get rid of the equals here. Which means our inverses are going to look more like that, and that would have been an open circle. And this one, well, it's going to be not there, it's going to be up here. It's going to look like that. It's going to look like that, and that this one will be a closed circle. Okay, and then D. Now, to do the square root of x squared, that's literally going to look like, because x squared's always going to be positive, yeah? So if x is 1, x squared is 1, square root of that is 1. X is 0, we're fine. X is 2, that squared is 4, square root of that is 2. 3, etc. X is minus 1, negative 1 squared is positive 1, square root of that is positive 1. So this is literally like the absolute value. So if we restrict our domain to here, then we're fine. So if we've got, oh, that's all we needed? Oh, we need to sketch this. So if we've got x equals root y squared, x squared equals y squared, x equals y. So if I want to sketch this, I also need to restrict it to x is greater than 0, so we're not going to have a negative x. It's literally going to be along here as well. Okay.